Welcome back. This is Mr. Tipton, and today we are working with dilations. Dilations, they are proportional enlargements, or that says deductions. Well, that's not right. Let's erase that. Proportional enlargements or reductions. That's making something smaller. And this happens according to a scale factor. Alright, to dilate a figure centered at the origin, all we have to do is multiply each ordered pair by the scale factor that's given. Okay, there are different ways to dilate figures. You can dilate them with the center being the x-axis or the y-axis. Right now we are only concerned about figures centered at the origin. Alright. So here this says dilate. It's supposed to dilate the parallelogram by a scale factor of 5. Okay, we've got a parallelogram on our coordinate plane, and I've already listed the ordered pairs for each of the points. Okay, the scale factor is greater than 1, which means it's going to give us an enlargement. Okay, this figure is going to get bigger because we are going to multiply every ordered pair, every number that we have here, times 5, and that's going to give us our dilated parallelogram. Okay, I'm even just going to put the 5 over here, kind of like we're doing distributive property. 5 times negative 2 is negative 10, and 5 times negative 2 is negative 10. Alright, the new point, technically it's a B prime. Alright, it's not still B, it's a new figure. Alright, on our graph, B is at negative 2, but B prime is at negative 10, negative 10. Okay, let's go ahead and multiply all of these. 5 times negative 2 for C prime is going to give us negative 10, and 5 times 0 is 0. So C prime is at negative 10, 0. For D prime, 5 times 2 is 10. 5 times 2 is 10. Our D prime is up here in the opposite corner. And E prime, again, times 5. 5 times 2 is 10. 5 times 0 is 0. So E prime is at 10, 0. Alright, and then I'm going to connect my points. I'm going to try and draw straight. When you draw the figures, you should be sure that they look, similar. Okay, these are proportional enlargements, so they are similar figures. If you end up with something pointed the wrong way or one side looks kind of funny, it probably isn't right, so just double check that you multiplied everything by the scale factor correctly. Yeah, so this is a dilation by a scale factor of 5. Let's do another one. We're going to dilate the rectangle, also a parallelogram. This time our scale factor is 1/3. When your scale factor is less than 1, what do you think happens? Yeah, it shrinks. It shrinks. Okay, multiplying everything by 1/3. I'll write that in there. 1/3, 1/3, 1/3. Kind of like distributive property. E is going to turn into E prime. 1/3 times negative 9. Okay, well, what's a third of 9? It's 3. And positive times negative is negative. And a third of 6 is 2. So our E prime is at negative 3, 2. F prime, a third of 9 is 3. A third of 6 is 2. So we're over here in quadrant 1. G prime, a third of 9 is 3. A third of 9 is 3. So we are at 3, 3 for G prime. And H prime will be at negative 3, 3. E, F, G, H prime. There we go. Okay, and I connect the dots, and I still have a nice and pretty rectangle. It's just been dilated by a scale factor of 3. All the side lengths have been reduced by a scale factor of a third. Okay, that's really all there is to it, to dilating figures. Just pay attention. Scale factors above 1, it's an enlargement. Scale factors below 1, but greater than 0, it'll be a reduction. There's other things that happens when scale factors get negative. If you have questions, ask me about it. Be happy to show you in class. See you soon.